Hello children, in previous video we have learned the geometric meaning of root of a linear polynomial. We know the standard form for the linear polynomial is ax plus b, and we have seen when we draw the graph for this linear polynomial ax plus b, we have seen that the graph intersects the x-axis at only one point. That means the linear equation having only one root. Now, in this video, we are going to learn the geometric meaning of root of the quadratic polynomial. Let us take a quadratic polynomial. Px is equal to x square minus 3x minus 4. We know the standard form of the quadratic polynomial is ax square plus bx plus c. So we can see this is the example of quadratic polynomial, as the highest power of variable in this polynomial is 2. So this is a quadratic polynomial. Now let us see how we will find the zeros of this quadratic polynomial. First of all, we will equate this polynomial with 0 to get the root of this polynomial. Now px is equal to 0 means x square minus 3x minus 4 is equal to 0. By splitting the middle term, we can find the factors of the polynomial x square minus 3x minus 4. See how we have splitted the middle term. Middle term minus 3x can be written as minus 4x plus x. When we split the middle term, we will see that the multiplication of these middle term should be equal to the multiplication of extreme terms. Multiplication of extreme term is x minus 4x square. Now see what is the multiplication of these middle term. Minus 4x into x, which is equal to minus 4x square. So we can see the multiplication of these middle term is equal to the multiplication of extreme term. Now when we will split the middle term, we will see that the sum of the middle term should be equal to the middle term of our polynomial px. So minus 4x plus x is equal to minus 3x. We can see. So in this way we can split the middle term. In class 8, you have also learned how to split our middle term. When we will split the middle term, and when we take x common from the first two terms, so what will remaining in the bracket? X minus 4. Now from the last two term, what we can take common? When we will take 1 common, so in the bracket it will remain x minus 4. Again we take x minus 4 common term, so x plus 1 and x minus 4 will be the two factors of the polynomial, which is equal to 0. So when we will equate x plus 1 is equal to 0, we will get x is equal to minus 1. This is the one of the root of the quadratic polynomial. And when we will equate x minus 1 with 0, we will get x is equal to 4. This is also one root of the polynomial. In this way, we are getting two roots of the polynomial, x is equal to 1 and x is equal to 4. These are the zeros of the polynomial. So by the algebraic method, we can see the quadratic polynomial has two roots, x is equal to minus 1 and x is equal to 4. Same thing we can verify with the graphical method, that the quadratic polynomial having two roots. When we put the different values of x in this polynomial, we get the different values of y. When we put x is equal to 2 in the polynomial x square minus 3x, we are getting y is equal to 6. When we put x is equal to minus 1 in the polynomial, we get y is equal to 0. When we put x is equal to 0 in the polynomial x square minus 3x minus 4, we are getting y is equal to minus 4. When we put x is equal to 1 in the polynomial y is equal to x square minus 3x minus 4, we are getting y is equal to 6. Same we can see x is equal to 2, y is equal to minus 6, x is equal to 3, y is equal to minus 4, x is equal to 4, y is equal to 0. In this way, we are getting the different values of y for different values of x. To plot the graph, we need these two values x and y. Let us see when we will plot the graph for this equation. which type of graph we are getting. The graphical representation of y is equal to x square minus 3x minus 4. Here you can see x is equal to 2, y is equal to 6. X is equal to minus 1, y is equal to 0, x is equal to 0, y is equal to minus 4, x is equal to 1. So in this way you can see that for the different values of x we are getting different values of y. When we are drawing the graph for this polynomial, we are getting the U-shaped graph, and clearly you can see the graph is intersecting the x-axis at two different points where the y is equal to 0. So graph is intersecting at x is equal to 1 where y is equal to 0, and another point at which the graph is intersecting the y x-axis at x is equal to 4 and y is equal to 0. So these two values where the graph is intersecting the x-axis are the root of the polynomial, or clearly you can see the graph is intersecting at 2 points. That means the quadratic polynomial having exactly 2 roots, and these are the value where the polynomial px is equal to 0 or y is equal to 0. So in this way we can say that with the graphical method we can also verify that the quadratic polynomial having exactly 2 roots, and these are the 2 points, and these are the 2 roots of the polynomial. Thank you. I hope you have understood the quadratic polynomial having exactly 2 roots.